Hello everyone, welcome to MRU E-Learning powered by Mallareddy University. As a part of today's lesson, we are going to learn about Introduction to Design and Analysis of Algorithms presented by Shanmukha Kumar from the Department of Cybersecurity and IoT, Mallareddy University. So today we are going to learn about what is the main basic of algorithm.
What is meant by algorithm?
So an algorithm is a sequence of unambiguous instructions for solving a problem which can be implemented on a computer. So unambiguous means problem solving methods. So problem solving methods means you can take any problem, a number of solutions will be followed. So under example you can take, so step-by-step procedure to solve a computational problem is called an algorithm. So computational means, so you can execute it on only computer programming. So you can give the problem. In a problem, you can give the number of solutions. So as I am giving to the algorithm to a computer, input to a computer, go to the computer, it will give the output. So process it and give the output. So it is a full-fledged definition of what is meant by algorithm. So problems that are not computational. Computational. So what the cure for the cancer? And how do I convince my boss to give me a high salary? This not comes on the computational problem. So what is mean? An algorithm is an efficient method to can be expressed within a finite amount of space and time and space. So what is mean efficient means fast execution. So you can take any algorithm, the efficient method to that can be expressed within a finite amount of time and space. So the important aspects of algorithm design include creating an efficient algorithm to solve a problem in efficient way using the minimum time and space. We can take any algorithm, number of possible solutions. In that it will give the less time and less space. That is the efficient by using the minimum time and space. So to solve a problem, different approaches can be followed. Some of them can be efficient and respect of time consumption, whereas the other approaches may be memory efficient. So two solutions vachesi some memory consumption and time. So what is the main properties of an algorithm? You can write any algorithm. These properties and merchant should follow these properties. So first property is input. An algorithm should be given 0 or more inputs. So for example, I am writing any algorithm, we can give the only output. So for example, you can take the hello world, it will give only output. I am not giving the any input to the keyboard. So merchant should input is an algorithm should be given 0 or more inputs. For example, I will add the two numbers A, B. So I will give the input from the keyboard. So that is the input. So output means at least one quantity is produced. For each input, the algorithm produces the value at the specific output. Whatever the program you have to write in, so you can give the input, and depending on input, at least one output merchant should give. Merchant will be displayed. So you can directly display the hello one, or otherwise I can give the values using keyboard, it will give the output. So definiteness. So each instruction must be clear and unambiguous. Whatever the program you have to write in, each instruction must be clear. So unambiguous. So don't confuse the compiler. Please add the x to 6 or 7. So add the x to 6 or 7. So this will the compiler will confuse. So no need to add this type of instruction. So each instruction must be clear and unambiguous. So next, finiteness. If the trace out the instructions of an algorithm, then for all the cases, the algorithm terminate after finite number of steps. Whenever you are writing any algorithm, finite certain of steps, it will be terminated. For example, you can take the while loop. After certain number of steps, it will be merchant should terminate. So it is a mean as finiteness. Effectiveness. Each instruction must be very basic so that it can be carried out in principle by the person using only pen and paper. So it must be very easy to understand. So next, algorithm continuation. So as a well-defined computational procedure that takes the sum values or set of values as input and produce some values or set of values as output. What are the input given to the problem? So that is input, and some values or set of values give the output. Written in pseudocode, which can be implemented in the language as programming choice. So in that algorithm is different, pseudocode is different, flowchart is different, and then program is different. So what is meant by basic pseudocode? Pseudocode is a simply an implementation of an algorithm. It can be annotation of informative text written in a plain English. So it can be a informative text written in a plain English. So pseudocode can be combination of programming language and human language. It is a combination of programming and human language. There is no particular syntax like any programming language, and it can be compiled or interpreted by the computer. So here I am taking the basic general example of the algorithm. So already we have discussed what is meant by algorithm, step-by-step procedure to solve some particular problem. Here I am taking the general example. So how to boil a water. So first of all, take a pot and fill it with the water. Place the pot on the stove, turn on the stove and heat the water until bubbles appear and it starts boiling. Turn off the stove, remove the pot safely. So this is the general procedure to how to boil the water. So here also they are following a step-by-step procedure to solve the problem. So in programming language also, how to add the two numbers. Before adding two numbers, I want how many values I will take? Two numbers. So addition of two numbers, start and then read the first number A. I am reading the first number A and then read the second number B. Add A and B. Sum equal to A plus B. And display the sum. This is the step-by-step procedure to solving the problem addition of two numbers. This is the basic definition and example of an algorithm. So generally how to write an algorithm? Here I am writing left side one algorithm, right side another algorithm. These two algorithms are similar. This output also similar. But there is no particular steps and particular procedure to algorithm. Depending on the design, you can implement a number of steps. So here I am taking same example. I am taking step 1, start, read the values A, B, C. If A greater than B, and comparison, if A greater than B, if I am taking any example, if condition is true, if A greater than C, these two conditions are true, then only print A is largest. So if the two conditions are true, A is largest. Else the two conditions are failed. Next go to if B greater than C, compare these two values. If B is largest, otherwise C is largest. After that we can stop the procedure. Same thing I am writing here also. Start and step 2, read A, B, C, and step 3, if A greater than B, then go to step 4. So same input and it will give the same output, but I am writing different ways. Here also, if A greater than B, then go to step 4. Otherwise, go to step 5. If the condition is true, whatever I am writing, this condition is true, it will directly jump to step 4 if A greater than C. Then here also, if the condition is true, print C is largest, otherwise print C is largest. So step 5, if B greater than C. So if the condition is true, B is the largest, otherwise if the condition is failed, otherwise print C is largest. So here I am taking the same example here and here, biggest of 3 numbers, it follows the some procedure. Here I am writing 4 steps, here I am writing 6 steps. But output is same. You can write n number of steps. We can step by step to solve a particular problem. So what is the main difference between the algorithm and program? So before going to you can write any program, you can design the algorithm. You can take any programming language, C, C++, Java, Python, must and should you can go with the algorithm. Algorithm is in the design phase. So programming in the implementation phase. For example, you can construct any one building. You can first map. Depending on map, you can implement the building. Otherwise, it can take problem and then deconstruct, you can construct the building. That is the problem. So before going to implement any program, must and should, you can design phase, and then depending on design phase, you can implement. Next, algorithm we can written the natural language. So easily understandable language, natural language, you can define the algorithm. What about program? Written in any programming language. So depending on C, C++, Python, so C means printf, scanf, and C++ means cout, cin. So Java, Python, depending on programming language, so written in any programming languages. Person should have a domain knowledge. Before going to write any algorithm, person should have a domain knowledge. So you can, same example you can take, you can construct a building, you can go to architect, depending on architect, we can draw one map, depending on that we can construct a building. Same here also, person should have a domain knowledge. Person should have a domain knowledge in algorithm, and the programmer, in a programming, programmer. Depending on language, you can write the program. So this is an algorithm is a analyze phase, and the program must be the testing phase. Whatever you are writing, whatever the input you are expecting, what the output they are giving. This is the testing phase of a program. This is the main difference between the algorithm and the program. So algorithm, specification. So specification of process is a translating a solution of a problem into an algorithm. This is done by 3 ways. So they are done by 3 ways. Instruction can be written by using the natural language. Instructions can be written using a natural language like English. In this case, we have ensured that the resulting instructions are defined. So graphical representation called. So whenever they were writing algorithm, they are represented in a graphical representation. It's called flow chart. And can be also used to specification, but they can work well only if the algorithm is simple and smaller. So when you are going to the flow chart, if it is very simple and smaller algorithm, then only go for the flow chart. So use of pseudo code is the most preferred option to specify any algorithm. It is represented by using the natural language, English, and C and C++. So issue in study of an algorithm. What are the main issues? So how to create an algorithm, how to validate an algorithm, how to analysis of an algorithm, how to test an algorithm, how to create an algorithm. To create an algorithm have the following design techniques. So these are the design techniques you can develop the algorithm. So what are first one? Divide and conquer, greedy method, dynamic programming, branch and bound, and backtracking. So what about validation? So validation of algorithm, once an algorithm is created, it is necessary to show that if compute the correct output for all possible legal input. So whatever the program you have to return, so whenever I am given the input, as per expectations, they are giving the output or not, as per expected output or not. So this process is called algorithm validation. So I want to find out the addition of 2 numbers. Whenever I am given the 2 numbers, 5 plus 4, I am expecting 9. So that is the validation. So how to analysis of an algorithm? Analysis of an algorithm or performance of an algorithm to task of determining the how much computing time and storage space is required. Whenever you can write any algorithm, how much time and space is required. How much time and space. So computing time, time complexity, frequency or step count method. So number of step you are written, number of input and number of outputs they are given. Storage space, to calculate the space complexity, we have to number of input used in the algorithm. So whatever the input they are given, so there is a storage space. How much data is stored. So how to test on a program? So program is nothing but an expression for the algorithm using any programming language. Using any programming language to test the programming, we need the following. So first one, debugging. So it is the process of execution program and a sample data sets to determine whether the faculty results occurs and if so correct them. Profiling or performance of measurement is the process of executing a correct program on data set of measuring the time and space it takes to compute the result and compute the results. So here I am taking a small pseudocode example. So what is the problem? Suppose there are 60 students in the class. 60 students in the class. How will you calculate the number of absentees in the class or number of absent in the class? So it is a pseudocode is a combination of English and mathematical. So initialize a variable called count to 0, absent to 0, total to 60. So problem already is given. There are 60 students in that. How to calculate the number of absentees? So find out the value of absentees. Initially count equal 0. So next step, for each student present to do the following. Increase the count by 1. So for example, if in the class one student is present, increases by count by 1. Increases count by. So initially count equal 0 and increases count by 1 means count equal to count 0 plus 1. So count will be 1. Then subtract count from the total and store the result the absent. So after finite number of step, for example, there is a 58 student. So display the number of absentees. So what of the remaining? So count will be 58. So total and store the result of absent. Absent equal to total minus count. So same program written in the algorithmic representation. So suppose there are 60 students in this class. How will you calculate the number of absentees in the class? So here also I am writing in the count initially 0, absent is 0 and total equal to 60. Repeat till all the student will be counted. Initially count to 0. Count equal to count plus 1. 0 plus 1. So count will be 1. And then 1 plus 1. Count will be 2. Same repeated until some number of steps. Absent equal to total minus count. So total already they are given. Total 60 minus 58. So obtain the number of absentees, which is 8. So this is the procedure to follow the step-by-step procedure to solve a particular program. So how can the performance of an algorithm can be analyzed? So how can your performance of algorithm can be analyzed? Depending on time complexity and space complexity. The performance of an algorithm can be analyzed using two main measures. So time complexity. So one measure of performance is the time taken by the computer to solve a problem using an algorithm for a given input size. Depending on input size, they can solve a problem, how much time it will take. Analyze the time required to solve a problem of a particular size is called time complexity. That is called time complexity. What about space complexity? Another measure of performance is the amount of computer memory. Computer memory required to implement an algorithm for a given input size. So analyzing the memory required for the algorithm is called space complexity. Memory is required for the space complexity. Time required to solve a problem, particular size is called time complexity. So consider the both time and space complexity is essential when the implementing algorithm. It is important to know whether the algorithm will be produce the results in milliseconds or minutes or even years. Similarly, the memory required to solve a problem must be available. Therefore, the space complexity must also be considered. Space complexity also must be considered. Space complexity is closely related to the data structures used in the implemented in the algorithm. So, what is the main definition of space complexity? The space complexity is an algorithm is the amount of memory need to run to complete. Amount of memory need to run to complete. So, speed needed by the algorithm is given by space needed by the algorithm is given by S of p equal to C of fixed part plus variable part SP. So, fixed part means independent of an instant characteristic. It is an independent. So, example, space for the simple variables and constant is a independent. So, variable part, so space of variable whose size is depend on a particular problem instant. That is the space complexity. So here I am taking a sample algorithm, name sum. I am taking 3 parameters. Initially, I am initializing a equal to 10, b equal to 20, c equal to a plus b. So a occupies 1 byte, b occupies 1, c occupies 1. So space complexity of S of p equal to c plus sp. So c means constant. So here constant 1 plus 1 plus 1. So totally 3 plus 0. So there is no independence. So 3 plus 0, 0. So order of n equal to 3. Order of n equal to 3. Next. So algorithm for sum. I am taking 2 parameters a comma n. Initially total equal to 0. And then for I equal 1 to n do total equal to total plus a of I. So return total. I am returning the total. Here I am taking the 1 space for n, 1 space for name, 1 space for I, 1 space for I, and 1 space for total. 1 space for total. So n spaces required for, and whenever I am taking the value of n, whenever I am taking the value of I, so total plus a of y, a of 1, a of 2, a of 3. So depending on n value, it will be repeating. So the n space is required for a of n, a of I. So we can, for example, it will give the 3 plus n, 3 plus n, 1 space, 1 space, 1 space. So 3 plus 1. So you can neglect about the number. So space complex equal to order of n only, order of n only. So next, what is meant by time complexity? What is meant by time? The time complexity as an algorithm is the amount of computed time it needs to run to complete. Amount of time it needs to run to complete. Here T of P equal to compile time plus execution time. Compile time plus execution time. T of P equal to TP execution time. So step count ela calculate chestaru? For algorithm headings. For algorithm headings it will take 0. For braces it will take 0. For expressions it will take 1. For any looping statement, number of times loop will be repeated. Number of times loop will be repeated. So here there are the basic 3 types of time complexities. First case, best case time complexity, worst case time complexity, average case time complexity. If an algorithm takes minimum amount of time for its execution, it is called best case. So minimum time, whenever I am taking any linear search, it is a step-by-step procedure to searching an element. So I want to search the 2. I want to search the 2. It will less time to search and execute, and it will find in the second position. It is the best case time complexity. Next, what about worst case time complexity? If an algorithm taking maximum amount of time for its execution. For example, I want to search the fifth element in a linear search. It will be searched by element. So it in the last position, it will take more time. So it is a worst case time complexity. So the algorithm taking maximum amount of time for its execution, it is called worst case time complexity. Next, average time complexity. If an algorithm taking average amount of time for its execution is called an average case time. I want to search the element 3. It will search from first onwards. So 3 is not there, and second also 3 is not there. It is found in the third position. So it is the average. So not less nor more. So it is comes under the average case time complexity. So these are the example I am giving the time complexity. So start, print number x, and then stop. So here there is no loop. So time complexity is called order of 1 only. So there is only one statement. So order of 1 only. Executes only once. So next, print number from 1 to n. So here I am using the for loop. So number of steps will be repeating. So start and read n for 1 to n, and then print the value of 5. So number of steps repeating means, so I am taking the value of n, order of n only. So time complexity of this algorithm is print a number from 1 to n is order of n. So here I am taking one more example. Algorithm algorithm name and parameter I am taking a comma n. So these are the statements say it will take 0 time, and the flower braces means it will also take 0. It is an one expression, so it will take 1. So for I equal to 1 to n do, 1 equal to I to n do. So number of value I am taken depending on n value. So it will be m plus 1, n plus 1. So s equal to s plus a of I. It is also dependent variable, dependent. So I is depending on I value. So s plus a of I. It is also number of times repeated. So n, the value. So and then return s. Return s. It will also one expression to give the 1. So after that, flower base it will 0. So total 2n plus 3. 1 plus 1 plus 1. So total 2n plus 3. This is the time complexity and algorithm. So next, what is the asymptotic notations? So the efficiency of an algorithm depends on the amount of time, storage and other resources are required to execute the algorithm. The efficiency measured with the help of asymptotic notation in the mathematical way. Asymptotic notations in the mathematical way. The algorithm may not have a same performance for different types of inputs. With the increase in the input size and the performance will change. Increase the size and performance will change. This study of change in performance of an algorithm with the change in the order of input size is defined as asymptotic analysis. Asymptotic notations are mathematical notations used to describe a running time of an algorithm when the input tends towards a particular value of a limiting value. What are the different types of notations are commonly used in performance analysis and used to characterize the complexity of an algorithm? So what are the 4 types? Big O notation, big omega notation, big theta and then little o. So what is meant by big O notation? So less than, the notation mainly represents the upper bound of algorithm. Upper bound of algorithm runtime. So big O notation is usually to calculate the maximum amount of time to execution. It will take maximum amount. So using big O notation, we have calculated the worst case time complexity. So here I am taking the f of n, g of n, the 2 non-negative functions. 2 non-negative means positive functions. Now the f of n equal to big O of g of n. If there exists 2 positive constant c, no such that f of n less than or equal to c into g of n. C is constant for all values of n greater than 0 and c greater than 0. So what about formula? F of n less than or equal to c into g of n. F of n less than or equal to c into g of n. So you are taking the graph. So the graph shows the how an algorithm actually time f of n compared with the upper bound of n c into g of n in big O notation. F of n upper bound of the c into g of n big O notation. For some values, f of n fluctuates due to the some constant factors and irregular behavior. After point n naught, f of n becomes stable, always stay below the c into g of n. This proves that f of n grows no faster than g of n, meaning f of n equal to big O of g of n. So here I am taking a simple example, you can satisfy the condition. Here I am taking f of n equal to 3n plus 2 and g of n equal to n. So formula f of n less than or equal to c into g of n. So satisfy the condition n greater than n naught, c greater than 0, n naught greater than or equal to 1. So now I am taking the 3n plus 2 equal to 3n plus 2, f of n equal to 3n plus 2 less than or equal to constant c into g of n is n. G of n is n. So 3n plus 2 less than or equal to c I am taking 4. C I am taking 4n. So put the value of n equal to 1. Here I am substituting the values n equal to 1. So 3 into 1. So 3 1 plus 2. 5 less than or equal to 4. Condition is fail. And then I am taking in place of n equal to 2. So 3 2s are 6 plus 2, 8. 8 less than or equal to 8, the condition is true. Now, for all the values of n greater than 2 and c less than or equal to c less than 4, if the condition is true, you can go for the n equal 3, n equal 4, it is satisfies the condition, but I want the maximum amount of time to execute. So, satisfy the notation, worst case complexity, minimum, least maximum amount of time to execute. So, we will take the, in this consideration, I will take the 1 satisfy the condition, 2 1 not satisfy the condition, 2 satisfy the condition. So, the above condition satisfy this notation, take the maximum amount of time to execute. So, that is called worst case time complexity. If condition is satisfied, so it will give the maximum amount of time to execute. So, what is the omega notation? So, greater than, it represents the lower bound of the running time. By using the big omega notation, we have calculated the minimum amount of time. Minimum amount of time, we can state that the best case time complexity. So, f of n greater than or equal to c into g of n. C into g of n. So, n greater than or equal to n naught, c greater than 0, n naught greater than or equal to 1. So, here we are, c is the constant. It will a lower bound on the best case time complexity. It satisfies the best case time complexity. So, here taking the graph shows the how an algorithm running time f of n compares with an lower bound of c into g of n. For smaller inputs, f of n varies irregularly due to the constant factors. After the point n naught, f of n becomes stable and always remains the below to c into g of n. Here I am taking a time, here I am taking the number of variables, t time, and the n is the number of variables. This demonstrates that f of n grows no faster than g of n, proving f of n equal to omega of g of n. So, here I am taking a simple example, f of n equal to 3n plus 2. Already f of n given the 3n plus 2. So, f of n greater than or equal to c into g of n. So, f of n 3n plus 2 greater than or equal to 1 into in place of gn, n. I am taking a g of n equal to n. So, here I am taking 1, c equal to 1. 1 into n. So, put the value of n equal 1. So, 5 greater than or equal to 1. The condition is true. The condition is true. So, it is the starting point only, the condition is true. It is the best time complexity. It means f of n equal to omega of g of n. Next, theta notation. So, asymptotic, it represents the average bound of an algorithm running time. By using the theta notation, we can calculate the average amount of time, so it is called average case time complexity of an algorithm. So, c1 into g of n less than or equal to f of n less than or equal to c into c2 into g of n. So, where c is the constant, n is the function, and it will follow the average bound. So, if the graph shows that, so the graph shows f of n bonds between the c1 into g of n and c2 into g of n after the point of n naught. For small input sizes, f of n fluctuates due to the constant factors. After n naught, f of n consistently stays between the two boundaries. This demonstrates that f of n grows at the same rate as g of n, meaning f of n equal to small o of g of n, big O of g of n. So, here I am taking the simple example. Here also I am taking f of n 3n plus 2, c1 into g of n equal to f of n less than or equal to c2 into g of n. So, here I am taking the 1 into n, g of n equal to n. So, 1 into n less than or equal to f of n 3n plus 2 less than or equal to 4 into n. Now, put the values of 1, it will get the 1 less than or equal to 5 less than or equal to 4. So, it is the false condition. So n equal to 2. So 2 less than or equal to 8 less than or equal to 8. True. Now we will get the 3 less than or equal to 11, 11 less than or equal to. So now value of 2, it is true. So above 2 can is satisfied. So it is the average time complexity. Average time complexity. So what about the little o? Little o notation used to describe an upper bound that cannot be tied. It other words, it lose upper bound of f of n. So slower growth rate and f of n grows slower than g of n. So let f of n, g of n are the functions that map positive real numbers. We can say that the functions f of n is small o of g of n if for any real positive constancy there exists an integer constant number less than or equal to 1 such that f of n greater than 0. So this is the little o notation. So thank you.